Hey, welcome to GeoSolve. This time we have a famous Olympiad question asked in 1980 Mathematical Olympiads in Holland. Using the information given on the question, we need to find the missing angle BAD. We will have 5 different solution methods for this question, and so this video will cover a lot of concepts in geometry. And if you're ready, let's start with the first solution method. First, let's extend angle bisector BD and intersect with line segment AC at point K. Then draw perpendiculars from point K to line segments BC and AB. Since line segment BK is the angle bisector, the length of these perpendicular line segments will be equal, and let's assume that they are x units. We can easily see that this angle is 60 degrees. So the hypotenuse of this 30-60-90 degree triangle will be 2x units. Now focus on this gray triangle. Using exterior angle theorem, we can see that this angle will be 20 degrees. Now focus on this triangle. Since base angles are equal, it's an isosceles triangle. So line segment DK will also be 2x units. Now focus on this right angle triangle. Using sum of internal angles, we can see that this angle will be 80 degrees. And since angles on a straight line add up to 180 degrees, this angle will be 40 degrees. Now focus on this triangle. We can see that angle K of this triangle is 80 degrees. So this angle should also be 40 degrees. Now focus on this triangle. We can see that angle A will be 50 degrees. Now let's drop a perpendicular from point A to line segment DK. So this angle will be 50 degrees. Now it can be seen that green and blue triangles are congruent. So line segment HK will also be x units. Since line segment DK is 2x units, line segment DH should also be x units. Now focus on this gray triangle. Since the height drawn from the vertex angle bisects the base, this is an isosceles triangle. So this angle will also be 50 degrees. And from the straight line we can easily see that our missing angle is 30 degrees. Now let's start our second solution method. First, draw another 10 degree line segment from point B and extend line segment AC to intersect with this new line segment at point L. This will create a 30-30-120 degree isosceles triangle BLC. And notice that we have another isosceles triangle here. So if we construct the height of the large triangle, it must pass through point D. This height will also bisect 120 degree vertex angle. Now focus on this shaded triangle. From internal angles of this triangle, this angle will be 100 degrees. Now let's draw an angle bisector from point L as follows. And notice that point F is the intersection point of angle bisectors of triangle LBD. So if we connect points D and F, line segment DF will also be an angle bisector. Now focus on this triangle. From internal angles of this triangle, this angle will be 50 degrees. Finally, let's focus on this shaded quadrilateral. Using the 50 degree angles, we can conclude that this is actually a cyclic quadrilateral. And so we can easily see that our missing angle and 30 degree angle are inscribed angles and they intercept the same arc segment. Therefore, they should have equal measure, which is 30 degrees. Now let's move on with our third solution method. First of all, let's focus on this triangle. And notice that this is an isosceles triangle with equal base angles. Therefore, its legs should be equal. Then draw a circle with center point at D and with a radius of these equal leg lengths. For the next step, let's extend line segment AC to intersect the circle at point K. After that, draw another radius of the circle connecting points K and center D. Now focus on this triangle. We know that its legs are the radius of the circle, meaning that this is an isosceles triangle. So base angles should be equal. Now focus on this purple arc segment. Its measure will be 60 degrees using the 30 degree inscribed angle. And therefore, the central angle subtended by the same arc will be 60 degrees. Before moving on, let's clear the diagram a little bit. Now let's connect points K and B and focus on the triangle we've just created. This is an isosceles triangle with a vertex angle of 60 degrees, which means that it is actually an equilateral triangle. So all three internal angles should be 60 degrees, which makes angle KBA 50 degrees. Now focus on this triangle. Using sum of internal angles, the missing angle of this triangle will be 50 degrees. Discovering the equal base angles of 50 degrees, we can say that this triangle is also an isosceles triangle. Finally, let's focus on this triangle, which is also an isosceles triangle with 20-degree vertex angle. Using the sum of internal angles of this triangle, base angles should be 80 degrees each. Therefore, our missing angle of the question will be 30 degrees. Now let's start with our solution method 4. But before that, please consider subscribing to the channel, and if you like this video so far, don't forget to give a thumbs up and leave a comment. Okay, let's go. This time let's start with drawing the circumcircle of the triangle ABC with center point O. And also draw these two line segments, which are also the radius of the circle. Now focus on this yellow arc segment. Its measure will be twice the measure of this 30-degree subtended angle, which is 60 degrees. Now let's draw another radius connecting the center and point A. And so this central angle will be 60 degrees. Now focus on this blue triangle. It has two equal legs and a vertex angle of 60 degrees, meaning that this is an equilateral triangle. So all internal angles should be 60 degrees, and thus this angle will be 40 degrees. Now pay attention to this blue triangle. We know that this is also an isosceles triangle. So the second base angle should also be 40 degrees. And also using the sum of internal angles of this triangle, we can find that this angle will also be 40 degrees. Now focus on this quadrilateral. If you notice, it's formed by two isosceles triangles glued back to back. So we can identify this shape as a deltoid. One nice property of deltoids is that their diagonals are perpendicular to each other. So let's pay attention to this triangle. We can see that the bottom 60-degree angle will be divided into 50 and 10 degrees. Also, let's write these 40 and 10 degrees as a whole as 50 degrees. And notice line segments BD and DO are equal due to equal base angles. Finally, let's focus on these two triangles with the isosceles triangle inside the equilateral triangle sharing the same base. This implies that line segment AD is actually the angle bisector of angle BAO. So our answer will be 60 divided by 2, which is 30 degrees. Now let's start with our last method, which will be a trigonometric solution. First, let's call our missing angle as A. Then the angle next to A will be 130 minus A. Now let's apply sine theorem on triangle ABD. From this triangle, we can write AD over sine 10 equals BD over sine A. Let's rearrange and call it equation 1. Now apply sine theorem on triangle ADC. From here we will have AD over sine 20 equals DC over sine 130 minus A. Let's rearrange the equation and call it number 2. And as you can guess, we will apply sine theorem on triangle BDC. From this triangle we can write BD over sine 10 equals DC over sine 10. Rearrange and call it equation number 3. Now let's multiply these three equations. And let's work on this equation to get the value of angle A. If you focus on the left side of the equation, you will notice that all terms will cancel out. So left side of the equation will simply become 1. Now if we cross multiply, we will have this equation. A little bit extra information here. This equation is actually the trigonometric version of Sivas theorem. If anyone is interested in this, you can look that up for more details. Continuing our question, let's focus on this sine 20 term here. And remember the identity of sine 2x equals 2 times sine x times cosine x. Using this identity, we will have this equation. Now let's simplify sine 10 terms from both sides. So this is what we have after simplifications. Now let's work on this part. And let's use this trigonometric identity. In our case, x plus y over 2 is equal to 10 and x minus y over 2 is a. Solving this system of equations, we will have x equals a plus 10 and y equals 10 minus a. So our main equation will become like this. Now focus on right side of the equation. We can write sine 50 plus a instead of this term. Let's rearrange our equation by adding sine 10 minus a to both sides. And let's clear the screen for the next steps. Now let's use the trigonometric identity on the right side for the yellow terms. Here our x will be 50 plus a and y equals 10 minus a. So the yellow term becomes like this. And we know that sine 30 is 1 over 2. So the equation becomes sine a plus 10 equals cosine 20 plus 10. And remember that sine x will be equal to cosine 90 minus x. If we use that property, we will have an equation like cosine 80 minus a equals cosine 20 plus a. Therefore, 80 minus a will be equal to 20 plus a. From here, 60 degrees will be equal to 2a, and a will be equal to 30 degrees. And that will be our answer. I hope you enjoyed this question and the solutions. Actually, there are a few more solutions to this problem, but I didn't want to lengthen the video anymore. If you want to see the other solutions for this problem, please let me know in the comment section. I'll see you next time.